Welcome to lecture number 2 of EDC. Today we'll study modes of Bjt operation. BJT stands for Bipolar Junction Transistor. We have studied about BJT in last lecture. A BJT can be an NPN or a PNP transistor with emitter, base and collector terminals. Each BJT has two junctions, base emitter junction and base collector junction. We have already studied about it. Uh, BJT has four modes of operation: amplification, saturation, cutoff, and inverse modes. In amplification mode, base emitter is BEJ stands for base emitter junction. Base emitter junction is forward biased. Base collector junction is reverse biased. For saturation mode, base emitter junction is forward biased, base collector junction is forward biased. Both junctions are forward biased. In cutoff mode, they both are reverse biased. The inverse mode, it is inverse to the amplification mode. We will in this course will study only BJTs only in amplification mode. Saturation and cutoff mode are used for digital electronics based applications, and inverse mode is rarely used. On this course we will study amplification mode only. There are three different configurations in amplification mode named as common emitter, common base and common collector. In common emitter configuration, base is used as input terminal, collector as output terminal, and emitter is common between base and collector. That is why we call it common emitter. So input side is base, output side is collector, and this is the most widely used configuration for BJTs in amplification mode. The operation is such that if we apply a positive voltage to base emitter junction, this base is p-type material, emitter is n-type material. If we apply a voltage across base and emitter, this is equivalent to applying a positive voltage across a PN junction. So this PN junction is forward biased because we have applied positive side of the battery to base, the p-type material, and negative to the n-type material. So that is why this junction is forward biased. So as VBB is around 0.7 volts if it is of silicon, and it is mostly of silicon, the base emitter junction is forward biased and an IB sets up. This IB gives rise to IC, and IC is beta times IB, where beta is current gain and has a value between 70 and 200. 100 is a typical value for beta. Since the output current IC is dependent on IB, BJT is a current control device. We'll study in later classes that FETs are voltage control devices because the output current ID would be dependent on input voltage. But BJTs are current control devices. Drawing characteristics. How can we draw input and output characteristics of this configuration? These configurations which we call as common emitter, because emitter is common between base and collector. So if we keep a constant value of VCE 1 volt, 10 volt or 20 volts, if we fix VCE at a given voltage and draw a graph between VBE, base emitter voltage, and IB, the characteristics are called input characteristics. VCE is kept constant. So we can draw different characteristics for different values of VCE. All these characteristics are like the characteristics of a PN junction, a diode. The important thing to note is that this current is in microamperes. So IB is in microamperes. It's a very small current. Right. The output character, to draw output characteristics, IB is kept constant. IB is kept constant, and we draw a plot between VCE in volts and IC, and IC is measured in milliamperes. IC is measured in milliamperes. So we draw characteristic curves for different values of IB, and as we know that these are different curves, and for a given value of IB we can compute different values of VCE and IC. In the lectures to come, we will study different biasing techniques for BJT, and we will skip common base. We will skip common base and common collector configuration, and these two configurations will be given as a homework. If you have questions about common emitter configurations, you can always post it on this group. Thank you.